Download this code from codegive.com, link in the description below. Bytearray out of range issue, a deep dive, addressing error 462/bkerler/EDL. The bytearray out of range error, sometimes associated with error codes like 462, the specific code can vary depending on the system and library, typically arises when you attempt to access an index in a byte array that's beyond its valid bounds. This tutorial explains the issue in detail, provides illustrative examples, and demonstrates how to prevent and handle such errors effectively. We won't directly address bkerler or EDL as these seem to be context-specific identifiers not directly related to the core byte array out-of-range problem. Understanding byte arrays. A byte array in Python is a mutable sequence of bytes. Think of it as a list where each element represents a byte, a value from 0 to 255. The length of a byte array determines how many bytes it can hold. Attempting to access an element using an index that's less than 0 or greater than or equal to the length will trigger an indexerror, byte array index out of range. Causes of the error. The most common reasons for this error are 1. Incorrect indexing *. This is the primary culprit. You might use a variable containing a value exceeding the bytearray's length, a calculation resulting in an incorrect index, or simply a typographical error. 2. Off by 1 errors *. A classic programming mistake, this happens when you mistakenly use len, byte array, as an index. Remember that indexing starts from 0. Therefore, the last valid index is len, byte array, 1. 3. Looping beyond bounds *. In loops iterating over byte arrays, improper loop conditions can lead to accessing indices beyond the array's limits. This is particularly prevalent when using range, incorrectly. 4. External data *. If the byte array is populated from an external source, example a file, network stream, incorrect data handling or unexpected data length can cause out-of-range errors. Illustrative examples and solutions. Let's demonstrate the error and its solutions with Python code. Example 1, Incorrect indexing. Solution *. Always double-check your index values before accessing elements. Use debugging tools or print statements to inspect index variables during runtime to catch potential issues. Example 2, Off by 1 error. Solution *. Remember that the valid index range is from 0 to len, byte array, 1. Example 3, Looping error. Solution *. Carefully design your loop conditions to avoid exceeding the bytearray's bounds. Example 4, Handling external data. Solution *. Always include comprehensive error handling, using try, except blocks, when dealing with external data sources. Verify file existence and data integrity before processing. Advanced techniques, bytearray.extend, and slicing. Instead of direct index manipulation, consider safer alternatives. *bytearray.extend, * adds bytes to the end of the byte array, preventing out-of-range errors due to appending. Slicing * allows you to extract portions of the byte array without the risk of accessing invalid indices. Example using extend, and slicing *. Debugging strategies. 1. Print statements * strategically placed print statements can reveal the values of indices and byte array lengths at various points in your code. 2. Debuggers * use a debugger, like PDB in Python, to step through your code line by line and inspect variables, identifying the exact point where the out-of-range error occurs. 3. Static analysis * use tools that perform static code analysis to detect potential errors like off-by-1 errors or incorrect loop conditions before runtime. By understanding the causes of byte array out-of-range errors and applying the strategies and techniques outlined above, you can effectively prevent and handle these errors in your Python programs, leading to more robust and reliable code. Remember to always validate your inputs and carefully manage indices when working with byte arrays.